Hi, welcome to this CAD Image PLM webinar where we're looking at the 3D sketching tools in Solid Edge. My name's Andy Rigby. I'm going to be running through the session. The plan for which is to take a practical look at the new tools in ST7, what they do, how they're going to work, why we should use them, some tips and techniques, and a few other bits and pieces as we go. I'm going to show an ordered part, a little bit of synchronous modelling as well. I think we'll start off with an ordered part. So I've thrown up a quick image there on the PowerPoint to show you where I'm going to go with this first example. So let's just have a quick look at ST7, a slightly new startup screen. Made some nice changes there. Let's fire up a new part. I'm just going to transition across into ordered mode to show you how this works in ordered, and then we'll do a synchronous example a little bit later on. So they've added in the 3D sketch tool to the toolbars across the top. When I select that, if I'm in ordered mode, then just like it does when you're creating a standard 2D sketch, it opens up a dedicated sketch environment. So it just is displaying the drawing tools, relationship commands, dimensioning tools, etc. It also changes the radial menu and gives me access to some of the standard commands as well. So if we kick off the line command, Solid Edge then presents me with some lines that are attached to the cursor, so you can see red, green, blue lines on the mouse. You've also got this triad, which is movable if you need to move it around, and it is useful to be able to do that. You can click and drag that around. Anybody who has used Express Route may be familiar with that triad as well. The base coordinate system is the one that's kind of displayed in this highlighted orange color, and I guess it makes sense really to show to start off the path, the 3D path that I'm about to create by using the origin point. You don't have to, but I guess that's a logical starting point. Incidentally, in the toolbar for the line command, we can create geometry that is parallel or related to a different coordinate system. So the fact that I've got base here indicates that, well, the base coordinate system is the only one in this model file. It's a standard template that I've opened, and those are the standard X, Y, Z axes, etc. So we'll start off. There's my starting point for my new 3D sketch. We have an input box for the value. We also have, IntelliSketch works in 3D sketches very similarly to the way that it works in 2D sketches. So as I move the mouse around, you can see it's snapping to the X, Y, and Z axis, and it's throwing on a little symbol as well. So as I move my mouse directly above the origin point, you can also see in the triad, this one on the left-hand side, that Solid Edge is highlighting that the Z axis is highlighted to indicate that if I was to create a line right now, it would be parallel with the Z axis. That's not quite what I want. I want one that's parallel with the Y axis, and we can type in a value, and Solid Edge places the line at the value I specified. What 3D sketching doesn't do at the moment is auto dimension. So I'll need to add dimensions manually as I go. I don't know at this stage whether or not that is just an oversight for this version or whether or not it's something they'll introduce later on. The next line I would like to fix to this YZ plane, and I can do that. You use this triad quite a lot in fixing the orientation of what you're drawing, either to a plane or to an axis. So if I click on the YZ plane, you can see that Solid Edge then places a little YZ indicator next to the mouse, and I have a couple of input boxes now. So we can make this line 200 long, and I can throw in an angle of 30. I'm still fixed on the YZ plane. That isn't what I want. I'd like to be able to create the next line along the X-axis of this triad, and you can move the mouse over the triad, click the axis that you want, and again you're getting lots of useful feedback on the cursor. The line I'm creating is parallel with the X-axis, and it's horizontal. So again, we can throw in a value, click again, say maybe I want to make sure that the next line again is parallel with the YZ plane, but I want it to be the same length as the first line, so I can move my mouse over a key point from the first line that we created and create a line that's parallel, and then we can stay set on that plane. And again, I just want to make sure this line again is parallel with or linked or the same length as the first line that we created, so we can use the base coordinate system and say, because I'm locked on the YZ plane, it'll keep the line I'm just about to create on that plane. You can use the right mouse button to reset the command, so rather than pressing escape and then pressing the line tool or starting the line tool again, if I wanted to start drawing from somewhere else now, I could do that. You can also see that because I'm fixed on the YZ plane or parallel to the YZ plane, that it's taken away the red line from where my cursor is as well. So that's got the path for this particular sweep. It's a sweep that we're going to end up creating. That's the path for it done. What I would potentially do then is we'll close this. I could create a second 3D sketch. And I'm going to use circle by center. Let's use a radial menu to grab that. Circle by center. We'll put it on the end here. And initially, the sketch plane, or the plane that it's creating that circle on, is parallel with my screen. You can see that. So if I change the orientation of the model, it will change the plane that it's actually drawing on. And this is really useful because it means I don't have to go around and create additional planes. So if I change the orientation, Control F to get a front view, you can see the circle. We can set a diameter on it. I might just add in a dimension this time for the circle. Close the 3D sketch and set the standard isometric view. So now I've got two sketches. I'll just need to go and make a slight modification to the first one, and then we can create a sweep. So because we're doing this in order, we can always go back and modify what we've done. What I want to be able to do is just add in some fillets. So we'll select two lines. We can set a value. So click for the first line, click for the second line. That'll apply a radius. Or if you move the mouse over a connect point, it highlights the two lines that are connected together, and it'll create the radius or the fillet in one click. We can also add in some dimensions, perhaps at this stage as well. So smart dimension, again, very similar operation to 2D sketching. It'll create dimensions between lines, on lines, radius values, angle values. So a couple of lines that are at an angle to one another. If I press A on the keyboard, I can get an angular dimension. You can also do that using the button up in the bar at the top there as well. So we can close a 3D sketch. So in a couple of sketches, and then we can very quickly lay out the geometry. So without all of the explanations, I could have done that even quicker. And let's just review how I might have done that, or probably would have done that prior to ST7. Well, I'd have ended up having to create 3 or 4 sketches. The first sketch, I could have created these first two lines, that one, and the angled line I would have ended up putting on the YZ plane. I then would have created another sketch on a parallel plane over here somewhere. So then I'd have created the flat and the angled line as a second sketch. Then I would have had to have gone and created another sketch. Plane by 3 points would have been a useful definition here. I don't have to create the planes first. I could do that as part of the sketch process. But I would have had to have created a sketch on this plane, and 1, 2, 3, those 3 lines there, or the line and the 2 arcs, I'd have created on a further in a further sketch. So that would have been 3 sketches created for the sweep, and then the cross section as well. So here I'm able to do a couple of undos and get rid of the planes. I'm able to do all of that in one single sketch, and that is a significant time saving that I'm getting from that. We'll add in our sweep. So here's the guide curve, here's the cross section, and there's our sweep. And we can always go back into any of the 3D sketches. Double click does dynamic edit just like it does in the standard sketch, and I can alter the angle. Notice it hasn't changed it's actually angled this line here, and we can see actually there's a relationship missing from that sketch line. There is one over here, but there isn't one on here. So IntelliSketch didn't add that automatically for me, so we can always go in and add it manually. So I just want to be able to create a parallel relationship between those 2 lines. We could also perhaps just do some horizontal vertical alignments and add in some more dimensions, but that's fundamentally how we'd get that to work. So a quick parallel relationship, and the model's been created, or at least it's been fixed. So we've got the sort of model that we're after, and then we could go further. That create some flats, put some holes in, thin wall it out, whatever it is that you need to do. So that's how the tools, or a bit of an introduction into how these 3D sketching tools work in ordered. Let's have a look at an example in Synchronous, and also model something in context. So this bar component, bent bar component, is missing from this assembly, and I'm going to go ahead and create it. So we'll pop back into Solid Edge, and we'll open up that assembly. Once we've done that, then we can kick off the process of creating this new part. So I'm going to isolate the view of the parts that will help us create this. We'll edit down into the assembly that we want this component to be placed in, and we're going to create a new component. Set a material, define the origin point for the part model, and give it a name as well. That takes us then into the model. We'll turn the view of the rest of the parts back on. So this is going to be a synchronous model, so slight difference to the way that the tools are presented. 3D sketching is just a tab that's been added to the interface, so I don't even need to click on this new 3D sketch command that's available. I can simply just go ahead and grab one of the drawing tools, and Solid Edge will add then the 3D sketch folder or collector or whatever you want to call it to the model structure for this synchronous model. I want to start this model off using some geometry that's in the model already. So at the end of this cylindrical cut, there's a circular edge. I'd like to be able to pick that up as the start point for my model. Solid Edge isn't picking that up at the moment, and that is because peer edge locate isn't on. So if I turn it on, I'll be able to pick up the edge. It's useful, to be fair, that it isn't on, because if peer edge locate is on, then in 2D sketching and 3D sketching, if you are modeling in context, or if you've edited into a model from an assembly and you're making some changes to some sketches or adding some sketches, what peer edge locate does is it allows you to select any key point from any component that you can see, and that can actually be a bit of a hindrance and a bit of a pain. That's why it's off by default, but at least I can turn it on. So hopefully that explanation has given you an idea as to what peer edge locate does if you weren't aware of it. So clearly you can see I can highlight that circular edge. You can use smart points or key point filters, shortcut keys. So I just pressed C on the keyboard to get the center of that circular edge, just like you would do in 2D sketching. Again, I can't see, I can see the XYZ triad. Let's just move it out of the way. Even if I couldn't, I know what the orientation of the XYZ axes is anyway, because I've got those blue, the red, green, blue lines attached to my cursor. So let's set a distance on that first sketch element. Again, this is going to be a swept feature that we're creating. If we change the view orientation, then we can bring the mouse down and we'll set some values. 130 mil. I'll just rotate the model around a wee bit, and it'll be useful perhaps just to drag the triad down a little bit. Now, in the first example, when I was setting the orientation for each of the sketch lines, I was clicking on elements in this triad. You don't have to do that. There are some shortcut keys you can use to do that. If I press Z on the keyboard, for example, it'll scroll through or toggle through each of the axes from the triad. So Z, press Z once, and it's the next element that I'm creating will be parallel to the Z axis or the X axis, or if I press Z again, it'll be the Y axis, and it quite nicely filters out, so it's clear exactly which axis it is that I'm creating this geometry against. And again, I don't have to see the axis to be able to do that, because I can also see next to the mouse I've got a little green Y arrow. Let's set a distance on that and then click to place. Z a couple more times and I'm creating geometry parallel with the X axis. And so what we can see is also Solid Edge is adding in connects between each of the lines. It's adding in those little parallel lines as well. Next thing I want to do is create an arc. So the sketch geometry I'm creating right now is to create half the model, and I'm going to mirror the second half of it. So this particular part, or this particular bit of geometry it needs to be an arc, and I want it to be parallel with the XY plane from the triad. And again, shortcut keys will help me pick that without having to move the mouse over the top of the triad and selecting those planes. X on the keyboard once gives me the XZ plane, and a second time gives me the XY plane. The line tool in 3D sketching works the same as the line tool in 2D sketching. So if I press A on the keyboard, I can create a tangent arc off the end of the last line that I created. Not too worried about the size here, but the angle of the arc would be useful. something about 90 degrees, and it's created, if I press escape, it has created that arc on a plane, say that's parallel with the X and Y plane from the triad, and that triad is orientated the same as the base coordinate system for this particular part. Back to the 3D sketching tools, it would be useful here to make sure that the center of this arc is located on the XY plane. So we'll use a connect to do that, and we'll also add in some fillets as well. So we'll run the fillet command. I think one of the advantages I've found is that because the sketching tools are a dedicated environment, the radial menu adapts. So I get the standard sketching tools on the radial menu, whereas here I don't necessarily get that if I'm using the 3D sketching tools in a synchronous model. Again, we'll add fillets as we did before. That looks okay, and then we will go in and add our cross section. So just before we do that, it'd be useful to know exactly what sort of size I'm after here. So if we go to the end of this circular cutout, we'll do a quick inspect on that. So inquire element, click on the circular edge, there's the diameter, that's useful, so it's 4 mil, so I'll need a little bit of clearance, but I can create a circular cross section now using the 3D sketching tools. Again, click the point, circle parallel with screen, not what I want, change the orientation of the model, changes the plane that the circle is on, and I'll just make that a little bit smaller than that diameter, so 3.8. I don't have to put a dimension on it, but it will be useful in case I need to change it later on, perhaps. We will then run the sweep tool, so swept command, path, and cross section. At this stage, actually, I don't really need the 3D sketch on anymore. It's not associative. It's not controlling this model anymore, and we can head off to the model structure. Pick protrusion 1. Grab the mirror command, and we can create the other half of this model. Now, any changes that I need to make, I'm going to make direct changes by selecting elements on the model. So, for example, the torus here, we can select. I can change the diameter of this entire piece, or actually, I'm more interested in just making that area a little bit tighter. Let's turn the view of the rest of the parts back on. So, at the moment, this doesn't really fit in this guide component, and it needs to. So before we do that, some relationships might be useful. I just want to make sure that this element here is parallel to faces on that guide component, and you can see it's moving 2 sides. I think it's just made a slight alteration there. And then the second thing is we just need to move all of these faces a little bit closer so it fits inside that guide. I'll pick up a couple of the extra cylindrical surfaces. Steering wheel manipulation. I'm just going to move this down a wee bit. It's still snapped to the center of that cylinder. The long piece on this new component, and I do need to offset it as well, so I can offset the steering wheel. I'd really like it to sit on the outside cylindrical face here, so 3.8 divided by 2. I can work it out as 1.9, but just to show you can add in little equations to those input boxes. We'll then move the whole model so it's seated on the inside face of this guide component. It's a little bit too wide. In fact, I think one of the relationships I created a little bit earlier on just pulled the face out a little bit. So we can again select the cylinder I want to move. In this instance, I don't have to fence select everything. It should all connect together because Live Rules is going to help me out here, and then we can move the whole thing across and connect it to that edge. Now for this, I mentioned a little bit earlier on about that peer edge locate. Peer edge locate doesn't have to be on to do what I'm doing right now, to be able to pick the circular edge. The peer edge locate tool is important for sketching elements, 2D and 3D sketching elements, but not move operations performed with the steering wheel. So that's got that component. Now seated inside that guide, that looks fine. So we'll close and return. Back up to the sub-assembly. Let's just turn everything on. So just to give you an idea of what the objective exercise was for this particular component. So we'll drag part, So this handle moves up and down, and so what that component is that I've just designed is the guide rail effectively for this to be able to pull the basket out of the fryer. We'll turn everything else back on. Actually, we can head up to the top level assembly as well. We'll show all of the components in this assembly, and what I'd like to do is just to make sure that the component we've just selected really needs to be connected or seated on the inside face of the pan here. So we'll grab those two components, spacebar to change the select filter, do a show only on that. If we change the orientation, we can see if we zoom in here that this piece of the bar isn't seated inside, it isn't tangent to the inside face of the bowl. So we'll just add that in we'll just make a modification to the part as well. So there's lots of freedom of movement in that component I've just created. And what I want to be able to do is just make that torus tangent to the inside face. And again, you can see the little preview. It's showing it's moving. It's now seated inside that face so that it's not going to move when we move the handle up and down. Let's just so that's our new component designed and finished, and an example of how this works. These 3D sketching tools work in Synchronous, and a little bit of Synchronous modeling stuff as well. So what else can we do with our 3D sketching tools? Well, we can use them to generate paths for frames. There's an example on the slide there of how how I've created a single sketch with multiple elements on multiple planes. To be fair, in the frame tool, if you do use it or have used it, then the line segment tool can do a lot of that for you anyway. but it's a nice tool to have, these 3D sketching tools in frames. We can use it to generate 3D schematic layouts as well. So I've done a simple one here, worked with a customer who had a requirement to do this in the past, and Solid Edge didn't really have the capability. I think that these 3D sketching tools have really given them the chance to do this in Solid Edge rather than using another product. So if we go back to Solid Edge, that particular drawing was generated from an assembly, and I've just changed some of the line styles. So here is here's the outline of the room with some heating or ventilation or pipe work or whatever it is, a schematic of that and the unit that it goes into. We do a quick double click, that takes us into, in this case it's an assembly, but it could be a part file, and I've generated 3 sketches, one for the room, one for the routing, and one for the unit. I think one of the advantages now of being able to do this in 3D is that I can change the orientation. So if I didn't want an isometric view, it wasn't showing that information particularly clearly, I can change it to a different 3D view, a trimetric or a dimetric view. That's not what I wanted. We want to go back to the PowerPoint. So you can use it to do things like that. You can also use it to create hoses, wires and cables. To be fair, you can do this in Solid Edge now, but what I just want to show you as a last example of how these tools might be utilized is just to open up one of the standard training assemblies where the screenshot was taken from. So what I want to do here is generate a new component that runs from this connector up here down to the port at the bottom, and it needs to be it's a hose perhaps rather than an actual piece of bent tubing. Would create a new part. I'll locate it on the end of the port. Not too worried about materials here. We can give it a name. I'll just replace the one that's already in that folder. And it would probably be best if we did this in order, because I'm going to use a 3D sketch tool really just to lay out the geometry that I want to use to create a spline. Notice there is no spline tool in the 3D sketching tools, and there doesn't need to be, and I'll explain why in a second. We'll grab the line command. I'm going to go ahead and eyeball most of this stuff in anyway, so I'm not too worried about putting in some dimensions to start with. A front view, I just want to run along the x-axis. A right view, we just need to run along the y-axis, so we'll pick that. Again, front view again, I just want this to run down. Let's move the axis down the z-axis, but it needs to line up with this port. And then we'll set the x-axis as well. and then finally the last part of this pipe run runs into that port at the bottom. So those lines will help us generate this spline. You notice that so there are various relationships that have been added. We can select those and delete them. It might be useful to add in some dimensions. That will help us control the path a little in a little bit when we generate the 3D sort of curve that runs through. So that's a good starting point. The tool we'll use to actually create this sort of bit of hosing is this key point curve command. Not new in Solid Edge, been around for a while, but this is why you don't end up having a spline tool in the 3D sketching tools, because you use key point curve to do that. So here's the start point for my spline. We're going to use the midpoints of each of the lines that we've created, perhaps, and then into the end. Not too bad, but we need a little bit more control. This spline needs to be tangent, really, the start and finish tangent to the ports that it's supposed to run into. So there are some nice controls that they introduced in ST6. Not so much the control, but these little handles, they were introduced in ST6, which really just make this process a lot easier to achieve. So I've got little drag handles. I can set how the tangency works to create this path. Tick the box, finish, and we're happy with that. And then in order to generate the cross-section perhaps that we're going to run along here, I could use the 3D sketching tools to do that, but we'll do something slightly different here. Maybe just copy a surface in to help define that. So we'll use into part copy to take a surface out of the assembly and put it in this part model, because I can then use that as the guide, as the cross-section for my sweep. So we'll add in a sweep. There's my key point curve is the path, and we can use the inside edge off this surface to define the diameter, or the diameter for this bit of hose. And then if I make any changes to this sketch, you can see that the path, the key point curve is updated. Let's turn the rest of the parts back on so I can make modifications to this path at any stage. If there's too much control, or I don't like the controls that I've got on the key point curve, then we can go ahead and we can remove the ones that we don't want, or I can add them back in again. So actually maybe we'll just look to remove. There's a little bit too much control. I've overcomplicated my path. And so the advantage of doing this in ordered is the way that that's just updated. So if this was synchronous, then the sweep would not be associative back to the key point curve, and that's kind of important, I think, in this little demonstration. So that's how we might generate that kind of swept component. You can just use, to be fair, you can just use key point curve to do that, but I've always found that I quite like the way that 3D sketching can be used to kind of create points in space that you can use to generate the path, rather than just trying to manipulate and modify those in space. And sometimes the key point curve tool, it can be a little bit fiddly sometimes to modify some of the points that run along the curve, that define where the curve goes. And that is how some of the 3D sketching tools work in Solid Edge. So hopefully that's given you an overview. You get the triad, which helps you define the plane or the axis that you're creating geometry parallel to. If that doesn't work, if that doesn't give you what you want, you can always create relationships, parallel relationships between one of the 3D sketch entities and an edge on the model, or you can generate your own coordinate system and make elements parallel to that. So we know what it does, we've seen how it works. The ability then to create cross sections, use it to generate help generate curves, key point curves. Why are we going to use it? Well, I think the first example was a good one, showing you where I just reviewed how you'd create all of those paths using the traditional 2D sketching methods, and how I'd have to end up generating 2 or 3 or more sketches to help create that component that we looked at first time. There's a general plan in mind to run another session later on this month, possibly on user interface changes that they've made in ST7. If you have a particular topic that you would like to see in a future webinar, please feel free to contact us. The contact details can be accessed through our website. The web page is listed at the bottom there. If you have any feedback about this session or any of the other sessions that we've run, please feel free to drop us a line, let us know what you think. And I hope you found this session useful. Thank you.